Right, so this question is coming from travel graph. Specifically, it is physics, science paper 1 for physics. So it is saying the graph shows the motion of a cyclist as she travels from one stage to the next in a race. Calculate question A. The acceleration from A to B. So we need to calculate the acceleration from A to B. So what was the initial velocity at A? So it was 0. Then the final velocity at B, it was 10 here. So we have 10 meters per second. So acceleration is given by change in velocity divided by change in time. So we can say that acceleration is going to be equal to the final velocity that we have here, which is the change in velocity. We have 10 meters per second. Then divided by the time. At which time did she reach the speed of 10 meters per second? So it was just 10 seconds. So we are going to say 10 seconds. So when I divide, the acceleration is going to be equal to, so 10 into 10, I'm just going to get 1.0 meters per second squared. So acceleration is measured in meters per second squared. So that is our answer for question A. Question B. The maximum speed of the cyclist. Of course, here they are talking about velocity, but they are asking us to give them the maximum speed of the cyclist. So we need just to obtain it from the graph. It's just this one here, which is 10 meters per second. So our maximum, we can just say maximum speed is equal to 10 meters per second. So that is the answer for question B. Then for question C, the total distance the cyclist travels. So what you need to know here is that the area under the graph, which is this one here, the area under the graph is equal to the distance traveled by an object. So in this case here, we need to identify the shape on this graph here. So the first shape from A up to B, this shape here, it is called a triangle. And then the next one, this one here, from B up to C, this one is called a rectangle. Then from C up to D, this one is also called a triangle. But from A up to C, this one can be classified as a trapezium. Okay, so we need to calculate now the distance traveled by the cyclist. So I'm just going to take the trapezium, which is this one, the whole thing here, then add it with this triangle. So let's do that. So we can just say distance is given by half, open bracket, A plus B, close, then multiply by the height, plus the area of the triangle, which is this one here. So we can just say half multiplied by breadth multiplied by the height. So now let's identify the values for A, the value for A and B. So the value for A and B, since we are considering this shape here to be a trapezium, so the value for A and B comes from parallel lines, or the lines which are parallel to each other. So we can just say that line BC is parallel to line AC. Okay, so the value for A is just going to be the distance from B up to C. So we are starting from 10, so we are just going to say and end at 60. So we are just going to say 60 minus 10, and which is giving us 50. So we have half, open bracket, 50 plus. Then the value for B, it is from A up to C. So from A up to C, it is 60. Then the height, it is from this point up to this point. Now we are having which value? This one here, which is 10. So we can say multiply by 10. Then we can say plus the area of the triangle. So the area of the triangle is starting from this point and end at this point here. So we can just say half. Then the breadth, it is from 60 up to 80. So we are just going to say 8 minus 60, which is giving us 20. So we can say 20 multiplied by the height. So the height, it is from this point up to this point, which is 10. So we can say multiply by 10. So let me just find the half of, so the half of 10, we are going to get 5. Then when I add 50 plus 60, I'm going to get 110. Okay. Then on this part here, when I multiply, I'm going to get 200. Then the half of 200, it is just 100. So I'm saying when I multiply 20 multiplied by 10, I'm going to get 200. Now the half of 200, I'm going to get what? 100. So here we can just say distance is equal to, so here we have 110 multiplied by 5, which is this one here, plus, so the half of 200 was what? 100. So plus 100. Now when I multiply 5 multiplied by 110, I'm going to get 550. 550 plus 100. So 550 plus 100, I'm going to get 650. So the answer is just going to be 650 meters. So this one is our distance, the total distance that the cyclist traveled. Question D. The acceleration from C to D. The acceleration from C to D. So we need to be very, very careful. We need to know the acceleration and also the retardation. So here they are just talking about the retardation, because from C up to D, she was retardating. So it was deceleration or retardation. She was decreasing in the speed. Similarly, we are going to use the same formula for acceleration, but what is going to change here is the final velocity and also the initial velocity. Okay, so over time, so the initial velocity is just going to be this one, starting from C. So the initial velocity is this one here, that we have here, which is 10. Then our final velocity, it is at D. So in time axis, C, velocity is going to be equal to 0. So our final velocity is just 0. So we can just say 0, then minus the initial velocity, which is 10 meters per second, divided by the time. So in this case here, the time we are going to obtain it from the graph. So she started decreasing her speed from C. And then the time was 60 up to D, where the time it is 80. So we need to say 80 minus 60. So 80 minus 60. Okay. So from there now we need to say 0 minus 10 meters per second, we are going to get negative. So we are going to get negative 10 meters per second divided by 80 minus 60, we are going to get 20 seconds. So when I divide, I'm going to get the acceleration, which is deceleration in this case here. It is just going to be negative 0.5 meters per second squared. So this one is our deceleration. Let's see the next question. So the next question is saying figure B2.1 is a speed time graph of an athlete in a training session. So we have the initial speed of this athlete, which is 3 meters per second, and the final velocity, which is 5 meters per second. Okay, so the first question is saying, what was the initial speed of the athlete? So the initial speed, it is just the speed at which this athlete started with. So this athlete started from 3. So we're just going to say 3 meters per second. So there is no need of you doing calculations here. Then B, what was the maximum speed of the athlete? So the maximum speed of the athlete is this one here. So you just need to take this one here, which is 5 meters per second, as the maximum speed. No need of you calculating here. C, calculate the uniform acceleration of the athlete. So here we are calculating the uniform acceleration of the athlete. So acceleration is given by final velocity minus initial divided by the time. So the final velocity is same as the maximum speed of this athlete, which is 5 meters per second. Then minus the initial velocity or the speed of this athlete, it was just 3, divided by the time. So what was the time when this athlete reaches the final velocity of 5 meters per second? So it was just 5 seconds. So we need to divide by 5 seconds. So we are just going to say 5 meters per second minus 3 meters per second. We are going to get 2 meters per second divided by 5 seconds. So in this case here, when I divide, I'm going to get the answer, which is 0.4 meters per second squared. So this one is our final answer for acceleration. The last question, which is D. Calculate the total distance learned by the athlete. Okay, so we have the first shape here starting from 3 up to 0. So this shape here, it is called a trapezium. We also have starting from 5 up to 20. This shape here, it is called a rectangle. So we have 2 shapes here. So we need to find the distance. So I'm just going to say distance is equal to, so we have the area of the trapezium, which is given by half a plus b multiplied by the height plus L multiplied by breadth, which is length multiplied by breadth, since the last shape is the rectangle. So let's obtain the values. So here we need to find the value of A and B for the trapezium. So we can just say the value for A, it is from 0 up to 3, which is 3. Then the value for B, it is from 0 up to 5, which is 5. So the value for A, it is 5. Then the value for B, the value for A, it is 3. Then the value for B, it is 5. Then let's come to the height. Height, it is this one, from 0 up to this 5 here. So the height, it is 5 for the trapezium. Let's come to the rectangle. So as for the rectangle, we have the length starting from this point up to this point here, which is 5. So the length being equal to 5. Then the breadth, it is from 5 up to 20. So 20 minus 5, which is giving us 15. So we have the breadth, which is 15. So let's answer the question now. So we are going to say half, then the value for A, it is 3. The value for B, it is 5. Then the height is 5 plus length, it is 5 multiplied by the breadth, which is 15. So what we are going to do here, we are just going to say 3 plus 5, which is giving us 8. Then 8 multiplied by 5, we are going to get 40. Then 40 multiplied by this one here, which is 1, we are going to get 40 divided by 2 plus 15 multiplied by 5, we are going to get 75. So when I divide 40 divided by 2, I'm going to get 20. So here we have 20 plus 75. So when I add, I'm going to get 95 meters. So our final answer here, it is just 95 meters. So that was the last one. Thanks for watching.